Hello and welcome to yet another tutorial uh, on bio-inspired optimization techniques. This time we will discuss about the well optimization technique. This and lots of different types of bio-inspired optimization technique tutorial can be found at baipatra.ws. So let us begin our tutorial. As I have said, this time we will discuss about well optimization technique. Okay, take an example problem. Suppose y is equal to x square and y is the objective variable and this equation is the objective equation. X is the design variable, right? And x varies within, say for example, -1 to 1. And our problem is a maximization problem. That means you have to increase the value of y by changing x. So this is our problem. Now the first step of well optimization technique is you have to generate solution randomly. Take for example, you can generate a 3 number of solution. Okay, this 3 number of solution can be 30 number of solution, 50 number of solution. All these solutions are randomly taken from the domain of feasibility. That means if this is y and you are looking for x square, right? This is x and you have said x must vary between -1 to 1. So you know I have to increase this because this is the minus x, this is the minus y. So the feasible domain is like this, correct? So feasible domain is like this, correct? So let it be -1, it is be 1. So this is your feasible domain and this is your infeasible domain. Because we have constraints in both sides of x. X has to be less than 1 or more larger than -1, but it cannot be equals to 1 or -1. This is the constraint given. So you have bounded this x, you have bounded the domain of solution. So this is your region of feasibility and this is your region of infeasibility. Now in case of well optimization technique, the first step will be to generate randomly any number of solutions, right? So here for example, to ease of understanding, I have taken only 3, but you can take n number of solution as you wish. More number of solution you take, greater amount of area within the feasible domain you can cover. However, the requirement of computation will also increase proportionally. So what we will do after generating 3 number of solution? 3 number of solution means take 3 values of x. Now you will put it into your equation y is equal to x square because this is the objective equation. Now for 3 values of x, there will be 3 values of y. As this is the maximization problem, we will always look for the largest value of y. And that will be the most optimal solution within the 3 generated one. Now what happened is that after generating these three random solution and putting into the objective equation, so you can easily identify the most optimal solution among these three. But yes, I have generated three, or you have generated n number of solutions, but it may happen the optimal solution lies not within this n number of solution, maybe out of this n number of solutions. So we have to do something to find more number of solution which can generate more optimal result. Okay, so now the well optimization technique step will start. After you have generated the solution, we say it as this, we say, or we refer this random generation of solution to be number of wells. That means if you have generated three number of random solutions, so we will say you have generated three wells. That means the swarm of wells have only three wells in their group, and they are now given the responsibility to find their food. Right? So what will happen? Let us see. Now in case of second step what we do is we generate a random value of p. This p, they often refer it as a random number. This p must vary between 0 to 1. It can be any value greater than 0, less than 1. Okay. Now if that generated value is less than 0.5, okay, if the this randomly generated value of p is less than 0.5, because your valid domain is 0 to 1, so there may be some values which is more than 0.5, and there may be some values which is less than 0.5. If they are less than 0.5 for an iteration, okay, then the next step is to check if absolute value of a is less than 1 or not. If it is, if value of p is less than 0.5 and the absolute value of a is less than 1, okay, then we will use the encircling formula. Now you will say, what is, sir, you have described that what is p? This is a randomly generated value within 0 to 1. Okay, we understood. Now, sir, what is a? From where on earth this a come? I will discuss in the next slide. But if your absolute value of a is less than 1, then you will use the encircling formula. Now your question will be, what is the encircling formula? Yes, this also I will discuss later on. Now if it is greater than or equal to 1, this the value of absolute value of a, then you will use the exploration formula, which is also known as search for prey formula. Okay, and then if the value of p is greater than equals to 0.5, you see the earlier condition was if the value of p is less than 0.5. Less than means less than 0.5, it cannot be equal to 0.5, because if it is equals to 0.5 or more than that, then you have to use the spiral position formula. Already I have discussed about two ways that humpback whales search for their food. This is the second way, bubble creek way or spiral movement manner, where the whales move like a 9. Clear? But when you will use this spiral position update or spiral movement? When the value of p that you have randomly generated within 0 to 1 is greater than or equals to 0.5. If it is not that, if it is less than 0.5, Then you question if absolute value of A is less than 1 or not. Then use encircling formula. If absolute value of A is greater than equals to 1, that means absolute value of A is equals to 1 or more than that, then you will use the exploration formula. Otherwise, if the value of P is greater than or equals to 0.5, you will use the spiral position update. So you can follow this A path, you can follow this B path, or you can follow this C path. Depending upon the value of small p and big A or capital A, this will be decided that whether you will follow the A path or B path or C path. And as is the norm for any bio-inspired optimization technique, after generating the solutions, you have to test the fitness of your objective equation. By fitness, we mean after you have put the value of x from those random solution, you will find the value of y, and we are into maximization problem, the largest value of y will win the game, or that will be referred to as optimal result. And for the value of x for which this optimal result has been achieved, that value of x will be referred as optimal solution. If the new value of x that we generate by the position update, which is an iterative process, as you know, at each iteration we generate new values of x. If within those value of x a more higher value of y is achieved, then we'll go with those value of x and refer those value of x to be more optimal compared to the earlier values of x. Now our next question will be that what is an encircling formula, what is an exploration formula, and what is an spiral position formula. You can say them as formula, or you can say them as position update method or technique, whatever way you may refer. And you also want to know what is this A, absolute value of A. So let us see what are they. Update method is known as encircling prey. Okay, so what is this encircling prey or position update technique? This is also referred to as exploitation phase. In any bio-inspired optimization technique, you will find a exploration phase, and another one is the exploitation phase. Generally, this indicates global search, and this indicates local search. What do you mean by local or global search? This is nothing but local search means within a very small domain you are searching for your solutions, and global search means within a large domain you are searching for the solutions. Generally what happens when the humpback whales chase a prey, then it can catches that prey only. So there is a chance that if they somehow fails to catch that prey, they will not have their lunch or dinner, because they have concentrated or focused on that single prey only. But when they follows that spiral position updating mechanism or bubble net mechanism, they are chasing a lots of prey at a one time. So if they misses one prey, they can catch us from the other. In case of optimization problems, if you only have local search, then your solution may be restricted within a specific domain among the feasible domain from where you are allowed to pick your solutions. But if you are with global search, you will get greater variation of optimal solutions. Okay. Now, what is this exploitation phase or encircling prey position updating method in case of well optimization technique? I have already discussed about the flow of the well optimization technique. Now I will discuss about this encircling prey method. In this case, D is equals to C dot x star t minus xt. Now you will say, what is x star t? X star t is that value of x for which the most optimal solution has been found. In our case, we are dealing with the maximization problem. So until that iteration, the value of x that has generated the maximum value of y will be taken as the optimal solution or best position, or often it is said as position of the best well. Best well means the well which has the highest chance of catching the prey. So you forget about well if you concentrate on the mathematical concerns. Then this x star t is the x for which the best y has been generated, and this x is the current solution that you have generated in the present iteration. Clear? And this c is actually a coefficient vector that I will discuss in the later on slide. So, and this d is actually referred to as the distance between the best solution and the new solution. Now this d we will put it into this equation to find the new value of x or a new solution. And there also this the optimal value of x or position of best well or the value of x for which the maximum value of y has been achieved will be there minus a new coefficient dot d. So this d and this d is same. This x and this x is same. The result will be a new value of x, which will be again you will put into the equation to find out the value of y, and then you will compare that new value of y with the old values of y. If your new value of y is greater than your old values of y, then new value is the winner. If not, the old value or the old value of y will be the winner, and we will go on with it. So this is the concept. Okay, now you will say what is A and what is C. So what is C and what is A? A is actually the coefficient which is equals to 2 small a dot r minus a. So what is this small a? This is a small value which linearly decreases from 2 to 0 over iterations. In one iteration, for the first iteration, you will take the value of a small a to be 2. Then you take the value of, in the next iteration, you take the value of small a to be 1.98, then 1.96, then 1.94, like this one. Anyway, the value will be decreasing from 2 to 0 at each iteration. So according to the number of iteration that you have considered, that this is the maximum number of iteration that I will iterate the problem, you decide how much amount you will reduce from 2 in the next iteration. Okay, so it will, but remember that it will always decrease from 2 to 0. And what is R? R is the random vector. That means it generates randomly any value within 0 to 1. And now this as I have said just now, that based on the number of iteration you will reduce the value of a from 2 to 0, and here is the formula for that. Value of a will be decided like this: 2 minus 2t divided by t max. Now you will say, what is t? T is the number of current iteration, and T max is the maximum number of iteration that you have allowed or you have desired to run the optimization. If you have desired to run the optimization 1000 times, then this T max will be 1000. And if you are at 500th iteration, then what happens? 2t, that means 2 into 500, that is equals to 1000. Correct? Then 1000 divided by 1000, 1, 2 minus 1, then the value of a will be 1 at the current iteration. So that is a very simple thing. Then you put the value of a random value will be generated within 0 to 1 as the value of r. This a and this a is same. So as a result of this equation, you will get the value of a. So that is all about coefficient vectors. Although they have been written as coefficient vector, for simplification you will take this as scalars. Vector they have taken because we have generated 3 wells at each iteration from the beginning. So actually a will be there for 3 wells, 3 different a will be there, 3 different r will be there. So that is why they are saying they are vector. Okay, otherwise you can take single value of the a, r, and then calculate a, big A, and then you put into your equation. C also 2 dot r, that means 2 multiplied by r. So that will give you the value of C. Okay, so just now we have discussed the encircling phase or encircling way to catch the prey. When the preys are encircled or chased, and the preys are concentrated into a center, that means, and when the prey is concentrated into the center, the whale starts to circle them. So that is, they say it as encircle phase of catching prey. Okay, so we have A, we have C. How we can calculate the value of A, we know. How we can calculate the value of C is, you know. So that is all about how to find the values of coefficient vectors at each iteration. This is about the bubble net attacking phase. I have already said that humpback whales can either chase the prey and concentrate them into a center, and they themselves rotates around it. So they encircle the prey, push them into the center, and then they try to catch it. This is one method, which is known as encircling of prey method, right? Another method is yours, this one, spiral update or exploitation, or it is also known as bubble net attacking. Here the whales move from below to surface. If this is the sea surface and this is the sea bottom, the whale move from here to here. And when they spot their prey near the surface or middle of the sea, what they do is they move in a spiral manner, and that is also in a shape like 9, the numerical digit 9. They move like this, correct? Then again 9, then again 9, and so on. And when they're moving, they generate bubbles, air bubbles, which create a wall around the prey and make this prey confused and motionless. Motionless means they are confused, they cannot run away at least. And that moment of their confusion, the whale catch them. Now this is mimicked in numerically the way I will describe now. So here also the value of x will come. The new position of x, which is indicated by x within bracket t plus 1. T is the number of iteration at the previous step. Plus 1 means in the new step. Okay. So this new value of x is given by d prime dot or multiplication with e to the power small b small l dot cos 2 pi small l plus x star t. As you can recall, this x star t is the most optimal solution, or the value of x, that value of x for which we have generated the most optimal value of y up to that iteration. Most optimal value of y means in our case the largest value of y until this iteration. This is that value of x which has generated that most optimal value of y. So this is the formula for finding the new position or new value of x. And this step will be followed if your value of p probability, which is a randomly generated number between 0 to 1, is I think greater than or equals to 0.5. Okay. Now how we will find this d prime? D prime you will find with deducting the previous value of x from the optimal value of x. This one and this one is same. This one and this one is same. Okay. Now what is small b? Small b is a constant, any constant of your choice, and small l is a random number which is generated in between -1 to 1. Any value in between -1 to 1, but not equals to -1, not equals to 1. Within this -1 to 1, any random value. Now this l, small l, this small l is same. Now b is any random constant you can take. Okay. Now this is the spiral update phase, exploitation phase. Now come to your exploration phase. So this exploration phase is I have already discussed in that search for prey exploration phase slide, where this is a random value of x which is generated in the initial step, first step, minus xt, this is the latest value of x, that will be equals to d, and this is the new value of x. So you put d here. A is that coefficient vector that I have discussed in the coefficient vector slide, and this d is this d, A is that coefficient that was also used in the encircling phase. X random is the randomly generated X at that iteration. And here comes the xt plus 1, that is, this is the new value of X, which you will put into your objective equation to find the new value of Y. That you do it each iteration. Now this fourth step and the fourth step I have already discussed is same, no difference. Okay, now that you know the encircling phase, exploration phase, and spiral update phase, now let us again revisit that slide which depicts the flow of the algorithm with the help of the value of small p and value of small, not small, big A. Correct? Let us move into that direction. That slide again. So, this is the next position update mechanism, search for prey. So, I think this is the B. This was marked as B, where we are discussing about the flow of the algorithm. So, search for prey, exploration phase. This is also known as exploration phase. So, what is that? Now this phase is followed, or this type of searching of prey is followed if the value of A is less than 1. And value of A means the absolute value of A is less than 1. So how to follow this? The formula is like this: D equals to C dot X random minus XT. In previous position updating mechanism, we have used the most optimal X up to that iteration. Now here we use X which is randomly selected or randomly generated solution. Okay, and this is the one of the wells that was among the 3 wells that was randomly generated at the first, or as the first step of the well optimization technique. So this is the X random minus xt is the current X, the new X that you have generated. That is also randomly generated. However, this is the new X which is generated at the tth iteration. That is why they are saying it as X function of X, function of t. X is a function of t, but t is here number of iteration. If that is the case, then you will use the similar type of formula to find a new X. New X means X for t plus 1th iteration. And that is what? Same way, similar way as that encircling phase. You will replace the X optimal with this X random. And you will use this coefficient A dot D. What is this D? This is this D. And remember, this C and this A is the same C and same A for the encircling phase. Of course, at each iteration, new values of C and A is generated, as you have already seen uh, at the coefficient vector slide, where I have mentioned about the formula to find capital A and the formula to find capital C. Okay. So here also what happens when the new X is generated, we put it into that objective equation and find a new value of Y. If that is the maximum value of Y, we go with that new X. If that is not the case, then we go with the old X. That is what we do in this phase. Remember, this is a phase which is follow if randomly generated value P is less than 0.5 and mod A is also less than 1. If greater than 1, then you will follow the encircling phase. Okay. sorry. So this flow of the, what I will say, this process that is followed in well optimization technique is also known as selection mechanism. So here you see with probability p, that means that randomly value that you have taken, you have generated at the first step, from the first step within 0 to 1. So if the random value p is less than 0.5, you will use the encircling or search for prey step depending on the value of big A, absolute value of big A. If it is less than 1, you will follow the encircling phase. If it is greater than 1, you will follow the search for prey or exploration phase. And if your value of P is greater than 0.5, then you will follow the bubble net attacking or spiral update phase. So this is as simple as that. So let us recapitulate again the entire method. So the first step of well optimization technique is step number 1. Randomly generate 3 wells. Now these 3 wells can be any number of wells. It can be 30, it can be 50, it can be 100, any number of wells. But at the first iteration, first step, randomly generate 3 wells. 3 wells means 3 randomly generated value of x. Clear? Then you put those values of x into your objective equation. In our case, it is y is equal to x square. Our objective is to maximize y. So you get 3 values of y. The y which has the largest value among all these 3 y is the optimal one. And the x that has generated that value will be the optimal x or best prey. Okay? Then at step 2, you generate a value of P randomly within 0 to 1. Clear? Now if this P is also referred as probability, but there is no relation with the main probability, the concept of probability with this P. This is P, randomly generated P. Any value within 0 to 1 not equals to 0 to 1, 0 or 1, that is P. Now if this value of P is less than 0.5, then you again question if the value of A is less than 1 or greater than 1. If the value of A is less than 1, then follow encircling phase. I have already discussed about this. If not, okay, then follow search for prey step. Search for prey step, or it is also known as exploration phase. Now if the value of P is greater than or equals to 0.5, then follow the spiral update or bubble net attacking phase, where the wells move in a spiral way from bottom to surface following a 9-like path. 9-like path. Clear? So in whatever phase you may follow, the end result of those phase is a new value of x, xt plus 1. Here t always denotes number of iteration, and t plus 1 is the new iteration. In some algorithm we use I, here we use t. Okay, and this a is a coefficient vector or a coefficient. How you can find the value of a, I have already discussed at the coefficient of vector slide. Please refer to that. And there is another coefficient also, which is capital C, right? And these both A and C will be used in the encircling phase and search for prey phase. So that is all about well optimization technique, or if you are writing an algorithm based on this, then it will be referred as well optimization algorithm, or WA. Okay, so with this we will finish this presentation. And remember, bubble net attacking phase is the exploitation phase where global search is conducted, and which also ensures that the optimization doesn't stuck into a local minima. And this encircling phase and search for prey phase both are type of exploration phase where a local space is only searched. Okay, but however, encircling phase is also an exploitation phase, because there also prey search is going on, and if optimal prey is not found, then we can go to the next location for the search of the prey, right? So that is all about well optimization technique. Thank you for listening. If you have liked this presentation, kindly share, like and subscribe to the channel. Thank you and see you next week. So it follows a two-step mechanism. So first, let me